All right, we're going to take a look at something called the triangle inequality theorem, and it has to do with whether or not a triangle can be formed with three given sides. Okay, and the main idea here is saying that in order for you to be able to form a triangle, the two smaller sides must, the sum of them, adding them up, should be greater than the largest side. Really, any two sides when added together should be larger than the other side, but mainly we look at it as the two smallest ones must add up to larger than the largest one. So let's go ahead and give this a try. I have three different examples here that we're going to take a an interactive look at to see if they can if they can work. So let's go ahead and start with this one. I'm going to tilt them just a little bit so that way we can move them on easily. All right, so let's go ahead and move this 5-inch one right here. And we'll keep it up here. We're almost going to make like a drawbridge for these. So that's there. And all right. So our goal is going to be to see if when we put these, on, if they will be able to connect and form a triangle. So, you'll see this kind of is similar to, if you know the drawing tool, a compass, where you put your, the one side of it right here. Let's see if I could pull a picture of a compass real quick so you can see. Geometry compass. All right, cool, here we go. So take a look at this. So this is what a compass is. It looks like this. And so the idea is it lets you draw circles. So, you could picture that one of those points is right here. So one of these bottom parts right here is right here. And then we're going to have the other one be right here, which is where the pencil would be. And it basically can allow us to draw a perfect circle. And so, we have it set at 5 inches right now, basically for this one side. And so we're going to go ahead and drag it and see if I turned this one and I did the same thing with this one. So we're going to rotate it again, kind of like a drawbridge, and see if these will connect. And look at that, there is a point of connection right here. So basically it's showing, this one might have to tilt just a little bit more, but it's, the fact that they do connect goes to show that a triangle can be formed. And the way that we can look at it with the actual theorem would look like this. So because the smaller two sides, 4 and 5, add up and are greater than the larger side of 8, this makes 9, that means that this can form a triangle. So let's take a look at the next one. All right, so here we have two smaller sides, both equaling 4. Let's go ahead and do our tilting a little bit. And I'm going to drag it on to form our triangle, or potential triangle. All right, so here we go. We have 8 inches as the largest, and we have two that are 4 inches. And if we were to bring these to each other and tilt them, we're getting pretty close. It's so close right here. But what you're going to find is that the two of these will never touch each other until, and this is going to, appear like it's touching, but the actual vertex of each line, are not touching. They are not going to truly be touching until they are laying flat. And this does not form the triangle. You'll see that the only time that these will touch is if they're laying flat next to each other, which is the exact same length as the 8-inch base. So this does not work. All right. So here's our, with the theorem, shows that because 4 plus 4 equals 8, because they're equal to the largest side, they cannot form a triangle. Okay. Picture again, this is actually like the perfect drawbridge. If we look at this one, this isn't really what a drawbridge is supposed to do. They don't connect, higher up. What they're supposed to do is you lay flat. So actually, this is like an exact drawbridge. This is the one that, this is one of the ones that will not work. All right, let's take a look at our last one. So here we have a 3-inch side. We have a, let's reset that. We have a 3-inch side, we have a 4-inch side. Let's go ahead and drag them on and see how this one works. And again, you might make predictions about whether this will work or not with our other examples. There we go. All right, cool. So if we were to, do the rotation, you're going to see that 3 and 4 are not going to reach each other. The same way that the 4 and 4 didn't reach each other until the very, exact bottom. This one just never will reach each other because 3 and 4, when added together, make 7, and that is less than 8, right? Those can never reach each other, even if they're laying flat, which wouldn't be a triangle anyway. So yeah, this one does not work. So just to show our 3 examples, we had the 2 smaller ones are less than the base, or the longest. That didn't work. When we have the 2 smaller ones equaling the base, that will not work either. And then lastly, we have our two smaller sides add up to being longer than that longest side of the base. And this one does work. So that's the general idea with the triangle inequality theorem.